we're going to begin with a guess. I'm showing you a picture. This is the geometric series, last lesson for chapter 9. All right? Geometric series, I want you to think about, look at this picture, and the question I have for you is what percent of this picture do you think is pink? Don't tell me, okay? Write it down and tell the person sitting next to you. Whisper it quietly, all right? Today I'm gonna show you guys how to add this up. This actually adds to a number or a percentage that we can actually verify. I'm gonna show you, but we have to save it for the end. So it's the clutch at the end. Okay, don't tell me what it is. I want to see how close your guesses are at the end. Okay, so here we go. Let's begin today with first idea here, and the first idea that we're gonna talk about is the sum. The sum of a finite geometric series. Okay? So let's just make up a series real quick. Let's start with the number 5. Let's say our ratio is 3. Okay? So what would the next term be if our ratio is 3 and I want to make a geometric series? What would the next one be? This one will be 15. Good. What will it be after that? 45. What would be after that? How much? 135. And then we'll do 2 more. What would they be? Ooh. 405? Is that right? Is it right? 405. 405. Good. We'll do one more. What would it be? 1,215. Really? Okay, awesome. So here we go. This is a finite geometric sequence right now, right? Because I have commas between these two. Okay. What does the word series mean? The series means that we're going to add these all up. Okay, so right now, in your calculator, can someone just quickly give us the answer to what this is, if you just add this up real quick? Nick, what do you got? What'd you come up with? Anybody? 1820, is that what you come up with? Yeah. 1820? Sweet. So we say this is 1,820. Okay, good. So that's our answer there, okay? It's a finite geometric series, okay? Well, it turns out that there is a formula for coming up with 1820. I'm going to show it to you right now. It takes quite a bit to develop this, so I'm going to just give you the formula. It's not like the arithmetic one where we could actually do that nice little proof. But it's similar in the fact that if we have a finite amount of numbers and we're dealing with a geometric series, we can actually add that up, all right? So here's what we did. We took the sum of the first, how many terms did we add up here? 1, 2, 3, 4, 5, 6. So we did the sum of the first 6 terms, right? It's going to be the very first term, which is 5, times 1 minus, what was our ratio that we came up with here? 3. Our ratio is 3, good. And how many times do we apply that ratio? 6 times, right? Check that out, right? All divided by 1 minus the ratio of 3. It would be amazing if that was the same thing as 1,820. Okay, this is the actual formula. I'm going to show it to you in a second, all right? But let's just play with this right now. Let's say, is this actually the same thing as 1,820? All right, let's go. Let's just do this. On the calculator, I'm going to do 5, parentheses, 1 minus 3 to the, what power do I have? 6, right? Okay, good. Bring my calculator down. And then get my answer. I'm going to divide that by what number? Wow, oh my gosh, divided by -2. No way, is that really the same thing? Ha! 1820. Whoa, look at that. That is amazing, right? Okay. So it turns out, yes, there is a formula for this, and what it is this. The sum of the first n terms, right? And we had 6 in my previous example. What did the 5 represent?
First term.
The very first term, good, awesome. 1 minus, what's the 3 represent? The ratio. What does the 6 represent? To the n, right? All divided by 1 minus, what's the 3 again? The ratio. There it is. Now that's a little bit, I know it's a little bit of hand waving on my part. I realize I didn't show you the proof for this. A little bit challenging. It does exist. Okay. This one would definitely be good to have in our head bank. The head bank. I like that one, okay? So definitely, right? So this is the sum of a finite geometric series. We want to have this one down. We want to put that in our notes, all right? All right, I'm really interested in adding up this particular series. It's a series, right? Is it finite? Yeah, it is, because it definitely ends right there, right? I only want to add up these first terms, right? Okay. I know that this series happens to be geometric. Here's the first term, here's the second term, here's the third term, right? So the very first term that I have here is equal to what? 3. What's my common ratio? My common ratio is 2. What's the only thing that I don't know? I don't know the number of terms in this case, right? Do I need the number of terms in this case?
Well, you do, but not until.
I do need the. I want to add this. I want to add this up. Like, I want to find the sum.
But you already know what the total is. Oh wait, no, you don't. Never mind.
I do?
No, you don't.
I don't, right? I want to find the sum. All right, I do need this, right? Because the formula calls for the n right here. I don't know how many terms I'm adding up, right? I need to know the number of terms. Is there a way that I could get this? Of course there is. I could use the explicit formula for a geometric sequence, right? So it says this: a sub n is a sub 1 r to the n minus 1, right? I can use that. I'm interested in knowing how many terms are in this sequence so that I can add them up, right? Okay. Oh, I know this. I know 3072 has to be the first term, which is 3, times the ratio, which is what I want, to the n minus 1.
I mean, 2.
Oh, yeah, I have the ratio. Good. Oh, let's plug that in. 2. Okay? So I have everything except for the n, which is the thing that I want, because I want to know how many terms are in the sequence. You guys follow along with this? Is this making sense to you so far? All right. What do I do now? Who's got a good idea? Divide by 3. I think that's a great idea. Let's divide by 3. Okay. What's that give me? 1024 is equal to 2 to the n minus 1, all right? All right. Can I change 1024 into a power of 2?
To the 10.
Yeah, very good. This is 2 to the 10th is now equal to 2 to the n minus 1.
Oh my
N
gosh.
equals to 11.
Who sees it? The MAIF. The MAIF. The most amazing fact ever, right? Okay, if 2 to the 10 is 2 to the n minus 1, it must be true that 10 is equal to n minus 1. Therefore, n is equal to what? 11. Awesome. So what does that mean, you guys? It means I have 11 terms, right? The 3072 is my 11th term. So what do I want to do with this, everybody? I want to add this up, huh? I want the sum of the first 11 terms. This one kind of worked out nicely. We could take a log and figure it out, but they won't get that complicated in this section, right? Okay, so sum of the first 11 would be what? It'd be 11 times... Oh, sorry, 3. Sorry, yeah, thank you. Got a little excited there. 3 times 1 minus... Yeah, the ratio is 2. I want to apply that ratio 11 times, all over 1 minus 2. Right? So what does this add up to? I'm wondering. So, I'm going to use the calculator for this part to show you guys. So, here's my calculator. Alright. For this part, I definitely recommend using the calculator so that we don't mess this up. So, I'm going to go 3, parentheses, 1, minus, parenthesis, 2, parenthesis, caret, 11. That's what I call it, right? Isn't that what it's called? Yeah, okay. Get that answer, and then divide by what? Divide by negative 1, exactly, because that's my denominator. So I'm getting 6,141. Oh, look at that. 6,141. So, this is a U-try, okay? And I'm going to give you a hint. This might be helpful for the formula. The formula. Okay, there, all you guys should figure that out. Anyway, here's what I would suggest you do. I suggest you guys write out the first couple of terms. See if you can see something. And what am I asking for? I want the sum of the first. How many terms are there? It goes from 1 to 20. There's 20 of those, right? 4 to the times 1 half to the n minus 1. Okay, ready to go. So do me a favor. If I was going to write this term, if I was going to write this sequence out, okay, what would the very first term be? If I plug in a 1, I get 1 minus 1 is 0. 1 half to the 0 is 1 times 4 is 4, right? Okay, so 4. Plus, what would the next term be?
2.
That'd be 2. What would the next term be? 1. So we're noticing something here, right? And I want to add this all the way up until I get to what? A sub 20, right? So, so yeah, that is the equation, right? This is the how part. This is the explicit formula for the geometric series, right? And then do you guys see how I'm like the formula, the R, right? The R is what? R is equal to 1/2, right? And if you don't know that, just take that number and divide it by that number. 2 over 4 is 1/2. Or even better, that one divided by that one, and you have it, right? Okay, so you should have had this. We want the sum of the first 20 terms is going to be the first term, which is 4, 1 minus the ratio, which is 1/2, raising that to the 20th power, all divided by 1 minus 1/2. Okay, I'm going to move this over so we can plug this into the calculator together, and we can get an approximate answer to this. So if I move this to right about there. Okay, so here we go, right? Did you guys do 4, parentheses, 1, minus, parentheses, 0.5, parentheses, caret, 20. Bring my cursor down, put my parentheses sign, hit enter. Yeah? And then 1 minus 1/2, how much is that? 0.5 divided by 0.5. So this is approximately how much am I getting from this thing? That, yeah. So this is approximately 8. All right, let's get some vocab here. I have just put on the board, I put 2 series on the board, but they're what type of series? Infinite. How do you know that they're an infinite series here? Yeah, the dot, 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 right? This implies that it goes on forever and ever, okay? They're both geometric. Both of them are geometric. Can you tell me what is the value of R in that first series there? R would be a value of what? 2. R is a value of 2. Everybody agree with that part? Okay. In the second series, what's the value of R? 0.5. R is equal to 1/2. Okay. One of these series converges, and one of these series diverges. Do we understand the difference between those two words? Okay. Who thinks they know? Hands up if you think you know. Flo, what does the word converge mean? Comes together. Okay, I like that. What else? Word converge. Anybody else? Brian, what are you going to say? He says get smaller and smaller and smaller. Okay. How about the word diverge? Right. Okay, so like if you're going to diverge from the path, you're going to go off and do your own thing, right? Or if you're going to if two people converge on a path, they meet at a point, right? So think about it like that. So if you had to guess, if you had to make a guess, which one of these sums converges and which one of these sums diverges? Because these are sums, right? Yeah, these are all sums. This is a sum and this is a sum. This is an interesting thing, right? Well, if they're both going to infinity, one of them actually can be added up and one of them cannot be added up. If you had to take a guess, which one do you think cannot be added up? The first one, it grows too big too fast. We can't put a bound on it. So do you think that word would be similar to something that is converging to a single point or diverging off to, there you go. Okay, so it's intuitive, right? So this one is divergent.
They actually use that word.
Yeah, that's the word that they use, right? The word is diverges, right? D-I-V-E-E-R-G-E-S, diverges. Yeah, these are actual words. Diverges, yeah. Or divergent, it's the same thing, okay? So this series diverges, which means it goes off and does its own thing, right? It cannot be bounded. However, the other one converges, all right? And these are calculus words, you guys. You're going to see these words all next year when you take your calculus course, okay? Converges. So this series converges, and the first series diverges. Now, there is something to be said for the reason why, and it has something to do with this value right here. What do you notice about these values? If you had to take a guess. Yeah, exactly. So if a geometric series converges, let me see, I'll make sure I down here they have the same way, okay? Then its absolute value of R will be less than 1. Its absolute value of R will be less than 1. Okay? Well, it's absolute value, right? Yeah, absolute value, okay? If it's divergent, then the absolute value of your R is going to be greater than or equal to 1. It'll diverge. greater than or equal to 1. It does not have a finite sum. It'll diverge off. Here we go. No, this is just examples for underneath 4. Okay? Here we go. Question. Does this particular series converge or diverge? Let's talk about A first. Okay? Well, what do you guys think? What is the value of r in this case? R is equal to 1/2, right? And 1/2, the absolute value of a half is less than 1, so this thing is going to what? This thing is going to converge. And it's going to converge because of this, right? Less than 1. Look at this second one, part B. This one's crazy, right? It's crazy, right? What is the ratio for this one? It's hidden. It's given to you. Yeah, this is the number that we keep raising to the power of n, right? The 2/3 is a constant. So because the absolute value of -5/4 is equal to 5/4, which is equal to 1.25, which is greater than 1, what does that imply? It diverges. So that's how you can tell right away what does what. All right, the last and final box is the last equation that we get to use. It's really fun. The sum of an infinite convergent geometric series. Whew, man. So what does that mean? That means that our ratio is, absolute value of our ratio is less than 1. If our ratio is less than 1 and it actually converges to something, we can find what it converges to. Okay? So the formula I gave you earlier in the lesson was this. The sum of the first n is, a sub 1 times 1 minus r to the n all over 1 minus r, right? Well, if you think about this, if I took this part of this, right? If I took r to the n, if my ratio was a fraction, like a half, and I raised that fraction of a half to a really, really large number because n is going to infinity. So what's a fraction raised to a very large number? A very, very small number. A very, very small number. In fact, it becomes so small, it basically becomes insignificant. So here's the formula for the sum to infinity, which is a very, very strange leap for us, right? How can you add something up that never stops adding? It goes to infinity. Well, basically what we're talking about is this thing called the limit, which you're going to learn about in calculus. And and the formula that we get to use is this, a sub 1 over 1 minus r. Now that should look really familiar to you. In fact, it kind of just looks like the one before it, but minus that stuff, right? Because that stuff becomes so insignificant. So for us, we get to apply this formula if we get to find the sum of an infinite convergent geometric series. Only works if your r is what? Absolute value is less than 1. That's the only way it works, okay? So it'll converge. Now take a look at this picture. This is my favorite example to show the demonstration of this. Earlier I asked you what percent was pink. And most of you guessed pretty close to what you think it might be. And this we can actually find this out. So let's actually write this sequence out. If I put a box around this, what fraction is pink of that entire square there? This is 1/4, right? So the first term I would have would be 1/4. And then I'm going to add on, how much is this stuff? That's 1/16, or a fourth of a fourth. Ah, okay, so I've got 1/16, right? How much would this one be? 1/64, right? And I potentially just keep going, don't I? Because, I mean, I can't really draw but if I could actually get really close, if I could zoom in on this thing, right, like all the way down and like just keep zooming in, right, it'd be crazy. But it goes on forever and ever, right? So, yes. So look, we get to apply this. The sum to infinity is, what's the first term of our sequence? 1/4, very good. 1/4 over 1 minus, what's our ratio? 1/4, right. So that is 1/4 over, what's 4/4 minus 1/4? 3/4. 1/4 divided by 3/4 is, holy cow, that actually is 1/3. As a percentage point, what would that be? Rachel says, how did I do that? Right? That's a third? Yeah, you could do that. Okay, so this thing is about what? 33 1/3, right, percent? Is that right? Is that a third? Right? Who came up with that? Who was closest to that? What'd you say exactly?
I said exactly.
You said 1/3?
Exactly.
1/3? 1/3? Yeah, pretty sweet, right?
Added like
Okay, here we go. Let's do this example. The sum, as n goes from 1 to infinity, 2/3 of the n. Okay? Let's write out the first couple terms. What's the very first term?
0.
No.
No.
If I plug a 1 in, what would I get? I get 2/3, right? If I plugged in a 2, a sub 1, a sub 2, what would that be? 4/9, right? 4/9, and I want to add this up until infinity, right? As n goes to infinity. Well, what's the ratio here? The ratio is 2/3, right? That's what it is. I'm applying the ratio every single time. So since that 2/3 is less than 1 absolute value, I know the sum to infinity has to be the very first term, which is 2/3, over 1 minus the ratio, which is 2/3. So I get 2/3 over 3/3 minus 2/3 would be what? 1/3? Right? Is that right? So what, this thing adds up to the number 2, exactly. The limit, which I know you don't understand what limit is yet because it's an Algebra 2 class, but you're going to get to calculus, you'll be describing that as the limit as n approaches infinity of that convergent series is 2. That's what that really means. All right?